Lucy! Here, Lucy! Here, Lucy! Come! Come on! Here, Lucy, hop up! Hoppy. I knew straight away that something abnormal was happening. Because you used to have always constant bird noise here, because we have so many bird species. I think there's been 178 bird species identified just around in this region.
But one day, 5 years ago, here on Brent Finlay's Cooinda farm in southeast Queensland on the East Australian seaboard, it got quiet.
And we were finding dead birds under a tree, like this tree we're just next to now. You'd go in there and there'd be dead birds on the ground. And a lot of those species haven't returned. There was no vegetable matter apart from leaves falling out of the trees on the land. No vegetable matter at all. It was all gone. It was dead. It was dead. As animals, kangaroos had walked on it, it turned to powder. And we had quite a bit of grass, but the grass was actually cooked. And you could see the kangaroo would hop across the grass. And every time they landed, the dust would fly up. And then you could stand back and look through the grass and you could see everywhere where the kangaroo had landed, there was bare dirt, because the grass had actually completely disintegrated, had fractured into powder. So our ecosystem, it didn't decline, it just collapsed.
After months of relentless heat and drought came a raging hailstorm in a neighbouring region that sent freezing winds across Brent's property.
It was so cold, they died of hypothermia. And under all these trees, there were just dead kangaroos everywhere. The kangaroos were poor because of the drought, but they were still alive. It killed, 6,000-7,000 kangaroos. I've never seen it happen in this region. And my father, who's 94, he'd never seen it happen before, and he's been on this property all his life. It was a mass die-off, driven by climate change.
Out here in Bigambul country, the landscape is bushy, with undulating hills and stacks of gum trees. And the climate is cool. They average about 650 millilitres of rain per year. Until 2018, the lowest in 140 years of records was a year with 330 millilitres of rain. In 2019, they got 125.
And at that stage, we were running about 5,000 sheep. So what we did right, it looks like we're going into a drought, we're going into a severe drought, spread all the animals out. Just give everything a lot of space is what we did. I then made a decision that this drought didn't look like it was going to break. All the remaining animals we had, we sold. We'd completely destocked.
And then, more than a year after the drought began,
and then it rained on the 25th of February 2020. That was the first time we had rain. It started and then we got rain another week later, and then another week later, another week later. The last thing you want is a big storm, because we didn't have any vegetation, but it would wash all our soil away. But because the rain was so gentle, it was like we've put you through a lot of trauma. We've put the ecosystems through a lot of trauma through the drought. We're now going to treat you really well and let it rain very softly on your land so your land can re-nourish. And that's what it did.
I'm here with Brent, 5 years after that drought, driving around on his 11,000-acre property in southeast Queensland, where he runs sheep, goats and cattle. The roos and the wallabies have returned, and so have many of the birds. The grasses and ants and insects are back too. They've had 4 good seasons now, but Brent knows that this won't last forever. You expect something like that to happen again?
Oh, yeah, it's and it will with climate change, and my understanding of climate change.
And while things are good in Brent's neck of the woods right now, 1,000 kilometres to the west of us, farmers are battling some of the worst flooding in recorded history, covering an area bigger than Texas and about half the size of Mexico.
So this is climate change, and we have to adjust to that. That's what we need to do.
He's done a bunch of stuff to the farm to ensure that they never run out of water again when drought hits. And there's also been another addition here.
We'll get up on a ridge over here and you'll actually see that there's 162 turbines in this project.
Wow.
At the moment there's 54 turbines turning.
Wind turbines. Dozens of them. I'd never seen a wind turbine up close before. As I gaze up and up to the tip, I'm squinting. It truly is colossal.
It's about 262 metres to the tip of the blade.
Wow. So it's like a high-rise building.
That's what it is, yeah. There's a high-rise.
The McIntyre Wind Turbine Project is the largest wind farm in the Southern Hemisphere. It's got 162 turbines producing more than 1,000 megawatts of electricity. That's enough to power 700,000 homes. Brent's got 45 of the turbines on his property, as well as a giant transmission unit that sends power to half of those homes. The wind farm is in its very last stages of completion. It'll be in full swing with all the turbines spinning and generating power by early 2026. By then, it'll have taken nearly 14 years for this project to come to life. Brent says it's been drawn out and complicated, especially trying to run his commercial farm at the same time. But overall, he feels good about it.
Gold standard wind.
Gold standard wind?
Yeah, it is so good.
What defines gold standard wind?
So gold standard wind means that predominantly, and today it's the same, it's the southeasterly wind blowing.
Though the wind here is of the gold standard type, it's still not ideal for radio, so I won't subject you to more of that tape. Basically, what Brent was saying was, where they're positioned here, sandwiched between a mountain plateau and a wide expanse of flat country, they get just the kind of constant windy wind that you want to consistently rotate those giant blades to generate power. Lots of it. Up close, the turbines look like giants, and the wind farm feels enormous. But if we zoom out, much further away from this corner of farm in Australia, these turbines are a small part of a much, much bigger global project to build out enough renewable energy to shift our entire energy system, to bring down deadly levels of emissions. But that, reducing emissions, isn't necessarily what motivated Brent. Alongside being a farmer, Brent is a landowner and a businessman. He says having the wind turbines on his property is an investment for future generations on this farm. It's additional revenue for the business, a form of economic security, so he and his family are better able to weather the coming climate shocks that could put them out of business for years on end. Because, I don't know if you've heard, but
climate change is expensive.
Because it's a ripoff. We pay $1 trillion.
From 22 to now, over $600 million is really significant.
We'll become poorer, weaker, and more dependent as a nation.
Or worse, by bankrupting us.
Cleaning up after climate change is already costing us a pretty penny.
But the thing is, not doing anything about climate change is going to be a whole lot more expensive.
The costs of not acting are much larger than the cost of acting.
There are these absolutely wild numbers that fossil fuel advocates are...
In this series from Living Planet, we're digging into the real costs of climate change.
Our feed systems collapsed, our biodiversity collapsed.
How we can reduce those costs.
And just how much there is to save.
In most areas, it's already much cheaper to do this. So let's just get on with that.
This is Living Planet. I'm Charlie Shield.
And I'm Sam Baker.
This is the second episode in our 5-part series on the costs of climate change. Today, we're asking, what might it cost to transition to renewable energy? And can we afford it? Okay, Sam, before we get into the nitty-gritty of the costs and the savings, the good and the bad, I thought we could have a quick recap on the why of the transition.
Like why we need to transition off of fossil fuels in the first place.
Yeah.
Okay. Do you want to start us off on that journey?
Yeah. Let me just dip back into the archives for a minute.
Weather. Everybody talks about it. From season to season, we have an idea of what to expect. But now, a growing number of atmospheric scientists are convinced that the climate is likely to change, and change dramatically. The reason is an odorless, colorless gas produced when we burn fossil fuels. It is called carbon dioxide.
It's possible that we could have very, very serious changes in global climate, in precipitation patterns, in wind patterns, and effects on agriculture, and effects on societies. It's hard for me to imagine a more serious environmental issue.
So that was a documentary from 1983. It was called The Climate Crisis, The Greenhouse Effect.
Fast forward to now, and we're actually living out some of those very, very serious changes.
A new UN report is warning that the world is on track for a temperature increase of more than 3 degrees Celsius by the end of this century.
That's an increase of 5.4 degrees Fahrenheit for our US listeners.
Thank you, Sam.
2024 was also the first calendar year more than 1.5 degrees above pre-industrial levels. The threshold, scientists warn, significantly increases the impacts of climate change.
For the last 170 years, CO2 emissions have been rising exponentially and accumulating in the atmosphere, heating up the planet and causing more extreme, unpredictable, and expensive weather. Lately, the climate's actually been heating faster than scientists expected it to. By far, the largest driver of this global warming is burning fossil fuels. These are the decayed remains of ancient plants and animals, buried deep within the Earth's surface and fossilised into coal, oil and gas over millions of years. Digging up these decomposed fossils and setting them on fire has been the industrialised world's main way of producing energy since the mid-1800s. In the process, massive amounts of carbon dioxide and other greenhouse gas emissions have been released and trapped in the atmosphere, where they stay for many hundreds of years. Today, fossil fuels are used to generate about 80% of the world's energy, even though fossil fuel companies and policymakers have known what causes climate change for decades.
So, TLDR, we need to get our energy from somewhere else as soon as possible, somewhere that doesn't emit potent greenhouse gases.
Exactly. And forms of energy that are renewable, meaning that they're infinitely available.
The need for energy, so central to our society, is threatening to alter the climate of the globe.
Fortunately, there are carbon-free renewable alternatives out there. Humans first invented technology to harness electricity from the sun, wind, from water and Earth's heat in the 1800s. The technology to tap into these sources of energy used to be really expensive, like $100 per watt expensive for solar panels in 1975. For context, that would have been $500,000 for a 5-person family-sized system of 5 kilowatts. That is very much not the case anymore. The global market price of solar panels is now roughly 10 cents per watt, and their costs have dropped by 90% in the past decade alone, which has helped them become a lot more popular. And alongside the solar business, that's got lots of energy strategists and economists very excited.
This is one of the world's most fabulous stories. If you go back 10 or 15 years, then the world is installing 1 gigawatt of solar capacity a year, and then it became a gigawatt of solar capacity a month. Then it became a gigawatt of solar capacity every single day. At the moment, it's now 2 gigawatts of solar capacity every day. And by the end of this decade, it's probably going to be around or at least 4 gigawatts of capacity every day.
That's energy strategist Kingsmill Bond from the UK-based energy think tank Ember, which tracks data and policy on the global clean energy transition. And this is climate economist Gernot Wagner from the Columbia Business School in New York.
Solar PV, cheapest source of electricity in history. This stuff is so cheap by now that Germans are installing them as garden fences. Literally, right? Not the best place to put your panel, right? Yeah, it's a solar panel, it keeps the dog in and keeps the car charged. Why not install it as a garden fence? And that's where we are, and it's only going to get cheaper.
So it is the most extraordinary story of very, very rapid deployment as people all over the world, from farmers in Pakistan to giant solar parks in the far west of China to households all across Australia or North America, just deploying this technology.
The graphs showing the exponential drop in the price of solar and wind technology and the rapid growth in their deployment do indeed look very promising. But as I've learned in researching for this episode, transitioning an entire energy system is incredibly complex, and there are a lot of moving parts, especially when you want to do it so fast.
How rapidly are we talking exactly?
Well, in order to limit global warming as much as possible, there are two important dates to keep in mind.
Mm-hmm.
Reaching net zero emissions by 2050 and tripling renewable energy capacity by 2030. The second one is crucial for the first one. So tripling clean energy capacity means reaching at least 11 terawatts of renewables by the end of the decade.
And how much do we have now?
So currently we have about 4.4, 4.5 terawatts, according to the International Renewable Energy Agency. We did actually add quite a bit in 2024, with China doing most of the heavy lifting.
So we still need to almost triple our entire renewable energy capacity in the next 5 years.
Yes. Because even though it's increased a lot in recent years, currently clean energy still only makes up about 1/6 of the globe's total energy mix. Coal, oil and gas still reign. There is still a huge amount of them to replace. Plus, new coal mines and oil and gas wells are still being built all the time. China, which is the world leader in building out renewable energy, it's also building the most new coal-fired power plants in the world.
So kind of a mixed bag, I guess.
Yeah, a mixed bag.
But I'm curious, why is China investing so much in both renewables and coal?
Well, the reasons are complex, but it's probably got a lot to do with energy security. So China, like many countries, wants to be able to generate its own energy, not to rely exclusively on importing fossil fuels, which is, incidentally, a major reason that they're investing so heavily in renewable energy. And since they have coal, they want to exploit that source as well. And the fossil fuel lobby is just as powerful in China as it is in the rest of the world.
Right. So if the renewable rollout is gaining so much momentum, they're getting so much cheaper, tripling is something that's still within reach, right?
It could be, yes. But currently, the International Renewable Energy Agency says that growth is not quite keeping pace with what we need to reach the 2030 goal. So it will have to speed up. And according to the International Energy Agency's latest analysis, the current energy policies of countries are not going to get us there. But it definitely depends who you ask. Kingsmill Bond, who we heard from earlier, he for one is very optimistic. He's worked as a financial market strategist for many years, first in the private sector for banks, and in recent years he turned his lens to how clean energy will shape financial markets and geopolitics.
To get to a tripling of solar and wind capacity by 2030 is nothing other than continuity of the current path that we are already on. And that's not to belittle it and suggest for a second that it's not difficult and it doesn't require huge amounts of work to make it happen. But we are, folks, on this trajectory already, and we just have to stay on it.
As Kingsmill mentions, it's difficult and it requires a lot of work. But he's convinced that the clean transition is well underway. And a lot of that has to do with the fact that it makes more economic sense to shift away from fossil fuels, and it won't be as expensive as many people think. We're going to dig into why that is after this short break.
I'm Carolyn Beeler.
And I'm Marco Werman.
We're With the World, Public Radio's leading global news program.
We cover the biggest news events developing every day and give you the context you need to make sense of them.
And Carolyn, I also like our smaller stories, tales of discovery and human kindness, things that make us laugh.
Stories that kind of shrink our world and make us feel more connected.
Subscribe and listen every weekday to The World.
Can we invest our way out of the climate crisis? 5 years ago, it seemed like Wall Street was working on it, until a backlash upended everything.
So there's a lot of alignment between the dark money right and the oil industry on this effort.
I'm Amy Scott, host of How We Survive, a podcast from Marketplace. And this season, we investigate the rise, fall, and reincarnation of climate-conscious investing. Listen to How We Survive wherever you get your podcasts.
And we're back. So, the goal is to triple current clean energy capacity in the next 5 years and reach net zero emissions in the next 25 years. That is crucial to avoid catastrophic levels of global warming. But how much investment will this transition need to develop, build, and install all the tech? The solar panels, the wind turbines, battery storage, upgraded power lines, and new grid connections. Estimations vary from about $1 to $5 trillion per year to 2030. Strategists such as Kingsmill tend to favour the figures on the lower end of the spectrum, around about the $2 trillion mark. That was a figure calculated by independent strategic research agency Bloomberg NEF. But here's the thing, even on the high end, experts say it's still less expensive than sticking with fossil fuels. In fact, a major study from the University of Oxford found that a fast transition to clean energy by 2050 will save the global economy at least $12 trillion. So why is it cheaper? Especially since we've already got all the gear in place for a fossil fuel system. Well, for starters, this system is just incredibly expensive to operate.
Your fossil fuel system is just so heavy and messy and dirty. You're shifting around 18,000 million tons of coal and oil and gas every single year to every corner of the world. And the minute they get there, you burn them.
Before you can shift the fuels around, you have to find them. That's exploration for oil, coal, and gas reserves. Then extract them. That's the mining and drilling. And then get the stuff to us across continents by trains, trucks, ships, and pipelines. But then there's another cost, added on top of all that, that's basically just profit. Because fossil fuels are concentrated in just a few regions in the world, the countries that sit on top of them can charge premium prices. Not just to cover costs, but because of the global demand for what they've got. Economists call this extra cost rent. It's not like paying your landlord, though. It's more like a scarcity bonus. Extra profit for having control of a rare and valuable resource. These super profits have made countries like Saudi Arabia, Russia, and Norway very wealthy and politically powerful. That is part of the reason fossil fuels remain so attractive for the people invested in them. Their potential for gigantic profits.
And the point is that we have a system which has got huge operating costs to run it. So we're buying the oil at $80 and we're pouring thousands of billions of dollars into the pockets of the petrostates and making them very wealthy. And it's that money that's up for grabs that we don't have to spend anymore.
And how much do these super profits add up to each year? According to data from the World Bank, it's up to $2.5 trillion.
So it basically, you invest to put up the clean energy system, and that will save you the money that you're currently spending on buying fossil fuels.
Essentially, what Kingsmill is describing is a reallocation, taking the money currently spent on fossil fuel profits and operations and redirecting it to build the clean energy system.
Alternatively, you just stick up a solar panel and it lasts for 30 years and generates you electricity every single day. You can absolutely immediately see that from first principles, it's obviously going to be cheaper to run a renewable system.
Because sunlight, wind and water are much more widely available and easier to access, there aren't really any super profits to be made or high operating costs.
We're currently spending, according to the IEA, around $10 trillion a year on energy in a $100 trillion global economy. So it's about 10% of global GDP is being spent on energy. Inside that, roughly, you've got $2 trillion of rent, about $4 trillion of tax, and about $4 trillion of operating costs for the fossil fuel system. If you move to a renewable system, you immediately lose the $2 trillion of rent, which is what people are fighting for, incidentally. And then, well, tax is obviously up to governments, but you will also have lower operating costs.
Now, yes, sunshine and wind are intermittent, which means if you want round-the-clock power, which we do, you need to store it. Battery storage has traditionally been pretty expensive. But like the panels and the turbines themselves, that's changing. In the 2010s, battery prices fell by 85%. And as the technology continues to improve, these costs are expected to fall even further.
The only fly in the ointment of the renewable system has been that fossil fuels can be stored, but electricity cannot, or could not in the past. And this is why we're getting so excited about the collapse in the cost of batteries, because suddenly you can put up a battery with every single solar panel. And that, again, is the great challenge of the next 10 or 20 years, is just at every country figuring out how to do it best.
Affordable battery storage is key. It'll mean households and businesses can store their power for use when the sun isn't shining and the wind isn't blowing, and take pressure off electricity grids. And this brings us to the second reason clean energy will be cheaper in the long run, because the technology for it keeps improving.
Coal prices have basically been constant, inflation adjusted, for around 200 years. The electricity generated from coal, it hasn't gone up in price, it hasn't come down either.
That's climate economist Gernot Wagner again.
Solar PV is a technology which gets better and cheaper over time, whereas coal is a commodity. It's only going to fluctuate. Coal, gas, oil are all commodities. Their prices are fluctuating. And by the way, that fluctuation is bad too. Right? That's where Putin blows a fuse, invades Ukraine, fossil prices spike, gas prices 10x in Europe, and we have the summer of 2022 when electricity prices in Europe were 10 times as high as they should have been. That is fossilflation. That's inflation caused by fossil fuel prices fluctuating. Solar PV, wind, hydro, geothermal, low carbon technologies don't have that problem. Those technologies can only get cheaper and better over time.
So, yes, building the clean energy system takes investment, but not more than we're currently spending on the dirty system, and the long-term payoff is cheaper, cleaner, more secure energy for everyone.
Okay, one question I do have, though. What about how our energy demands are increasing with economic growth, particularly in emerging markets and, of course, the tech sector? How will that affect scaling renewables up?
Yes, so that's an interesting one, because on the one hand, there are people like Kingsmill who say that the claims about AI and computing immeasurably expanding our energy demands beyond what renewables can cover is just hype. That's an excuse used to justify delaying a transition.
So AI is simply the latest bogus argument being made by the fossil fuel folks to try and get us to build more gas-fired power stations and nuclear power. If you take the most aggressive expectations from the IEA, for example, of the growth of electricity for AI, then a single month of new solar deployment would be enough to supply a year's worth of expected growth from AI. So again, it's a very small thing that has been built up to be a very big thing, and it's something we need to think about. It's very important for Ireland and specific locations, obviously, but for the global debate, it's simply not especially material.
But then again, it's not just AI that's increasing our energy use. It's also data centers for crypto mining, which are actually a key driver of the skyrocketing growth in electricity demand.
Oof.
They could, of course, be powered by renewable sources, but that might eat up precious energy that would ideally power homes and businesses to get them off fossil fuels as quickly as possible.
I knew there were reasons to be skeptical of crypto.
Right.
But I heard Kingsmill mention nuclear power there too. Isn't nuclear clean energy? Why is he writing it off?
Yeah, so this is where we should probably quickly mention nuclear power. Google, Microsoft, and Amazon have all recently struck deals for nuclear power to fuel their growing demands in AI. And nuclear is a better alternative to fossil fuels because it doesn't emit carbon dioxide or pollute the air. But compared to other renewable energy sources, it's very expensive and it takes a really long time to build. And because of that, innovation in the sector is also a lot slower.
Right, so it's not going to help us reach those 2030 targets.
Exactly.
But data centers or not, our energy demands are generally growing at a faster rate. They just keep growing and growing, right? Especially in the global south.
Yeah, that's true. And that has some really big implications that are also very important to mention here. Because just swapping out fossil fuels for clean energy will not necessarily magically solve all of our problems. Renewable infrastructure requires some stuff that's quite hard to get and can be pretty detrimental to environments, often in the global south. And because of that, there are a lot of researchers who argue that as the world undergoes this transition, we need to remember that all energy systems have a cost.
Right. So in the case of renewables, you need precious metals, critical minerals for not just the technology itself, but especially the batteries.
Yes. And these precious metals, critical minerals, they're often mined in poorer, more biodiverse areas and on lands where traditional Indigenous groups live. So things like lithium from Australia, for instance, it also comes from Chile and Argentina, chromium from South Africa, copper from Chile.
Cobalt from the Democratic Republic of Congo.
Exactly. And so in order to minimize the harm from this mining, these researchers say that scaling up renewable energy capacity, while essential to bringing down emissions, this needs to happen alongside a reduction in consumption.
And how's that going to happen?
It is kind of hard to imagine, but it could take different forms. So, for example, we tend to want the biggest and newest version of everything, or at least that's what's advertised to us most aggressively. But if we downsized and invested in sharing a bit more, we wouldn't need so much of this technology and therefore not as many critical minerals. So that could look like smaller electric vehicles, for example, as well as car sharing instead of owning. And it could also look like a lot more good, affordable public transport and cycling and walking options for people.
And okay, last thing, but what about those sectors that we can't even use clean energy for yet? Like air travel, steel, cement?
True. There are still industries that renewables can't power, like you mentioned, aviation, steel, and cement, and those make up about 20% of carbon emissions, which is a really decent chunk. For the time being, those are going to remain fossil fuel powered, but this doesn't mean that we won't find solutions to clean those industries up as the technology improves. And that still leaves us with 60% of our current energy sources that we can replace with renewable energy. And that is a whole lot of emissions.
Right. So we should focus on what we can change now and work on the technology for everything else to catch up in the future.
Yes, basically. Here's one last quip from Kingsmill Bond on that exact note.
If you are climbing a mountain, then you need to get through the foothills before you figure out how to get to the peak, the last 100 meters. And, we're still in the foothills of this transition. So let's just get on with, just trudging through the foothills up the gentle slopes surrounded by trees and streams. We're not yet in the alpine regions where we need ice axes and stuff. But what we do need to be doing at the same time as we deploy good solutions in areas where they work, we do need to get entrepreneurs and our governments to be putting time, effort and money into solving these more difficult problems.
And that last point he makes gets to the heart of the challenge here, which is that, yes, clean energy technology may be cheaper than ever. And for all the reasons outlined in this series, certainly cheaper than a fossil fuel-based system. But a lot of the transition still hinges on policies and government decisions. And according to Gernot, it'll take more than just cheap technology.
You and I, as consumers, don't care where our steel comes from, don't care where our cement comes from. Right? We're not going to pay more for steel. We're not going to pay more for cement unless there's policy that frankly forces the companies to produce cleaner steel, that makes the clean relatively cheap compared to the dirty. So it's not going to be corporate volunteerism that will guide us in the right direction. Of course, it takes policy overall to guide society, the economy, businesses in the right direction.
To me, I don't mind them at all, and I'm looking out the door here now at 100 plus turbines. Some of them are spinning, some of them aren't spinning. I think they're an incredible engineering feat. When they're turning and they're moving and the sunlight's catching them, and they are quite spectacular. And I've been looking at them now for no more than 12 months.
Back at Coinda Farm, Brent says that he's heard lots of different opinions in the community about the aesthetics of wind turbines. But it's something quite different when they are, quite literally, in your backyard.
I think it's like if you live in a city, you don't actually see the city all the time as this big thing that stands out. Sometimes it's something that's interesting to look at. I think this is something similar to that, and I think we'll adjust and get used to it.
In any case, it's a price he's willing to pay.
Our family's been here for 100 years, and it's a 30-year contract that's on these turbines with a potential renewable option for another 30 years. This is intergenerational income stream from another industry that's not dependent wholly and solely on the climate that we manage, the rainfall that we receive, that feeds our pastures and that sunlight. Now we're farming the wind as well as farming the livestock that we have on this property.
As for how we could fund this transition, where investment could come from, how governments and the private sector can reallocate funds to bankroll it, and what savings we might expect alongside it,
I'll be covering that next week in episode 3 of our series on the cost of climate change.
The best way to describe it, honestly, is the way you would go in, if you go into a classroom of grade 4 students, which I would do, I'd say, do you think it should be free to pollute? Like, they'd be like, no, no. And so, like, then you kind of are winning when you say, like, it cannot be free to pollute. There's a cost. Everyone kind of understands that, even if you're a grade 4 student.
This episode of Living Planet was reported and produced by me, Charlie Shield, along with Sam Baker. It was edited by Neil King and mixed by Neil and me. Our sound engineer was Gerd Georgi. What did you think of this episode? Do you have questions about the costs of climate change? We'd love to hear them. Send us an email or a voice note to livingplanet@dw.com. And if you're a fan of the show, it would make us enormously happy if you left us a rating and a review on Apple Podcasts or Spotify. Living Planet is produced by DW in Germany.